Somewhere in the United States right now, two people are thinking the same thought. They want the same outcome. They make the same effort. They even believe, consciously, in the same idea of success. Yet months later, one of them watches life rearrange itself almost effortlessly in their favor, while the other feels as if the universe itself is resisting every step. To most of us, this difference looks like luck, or privilege, or coincidence. But physics, quietly and indifferently, offers a far more unsettling possibility. For more than a century, quantum physics has been dismantling our most comfortable assumptions about reality. It has shown us that matter is not solid, that certainty is an illusion, and that observation itself plays a role in how events unfold. At the smallest scales of existence, particles do not behave like objects moving through space, but like probabilities waiting to collapse into fact. The universe, according to modern physics, does not merely happen to us. It responds. This is not mysticism. It is not motivational folklore. It is the documented behavior of reality at its most fundamental level. And yet, when these discoveries leak out of laboratories and into culture, they collide with a deeply human question that science has never fully answered. Why do some people seem to align with outcomes so easily, while others struggle endlessly against invisible resistance? Throughout history, humans have sensed that thought, expectation, and perception play a role in shaping experience. Ancient philosophies hinted at it. Early psychologists circled around it. But only with the rise of quantum mechanics did science stumble onto a framework where such ideas could even be discussed without immediate dismissal. Not proven, not endorsed, but no longer impossible. The unsettling implication is not that thoughts magically bend reality, but that the boundary between the observer and the observed is thinner than we once believed. At the quantum level, the universe does not fully decide what it is until it is measured. Outcomes exist as clouds of possibility, not fixed destinations, and the act of observation is not passive, it is participatory. If that is true, then the question shifts. It is no longer why some people are lucky or gifted or chosen. It becomes something far more uncomfortable. Are some people unknowingly better aligned with how reality actually works? Tonight, we are not selling certainty. We are not promising miracles. We are examining the narrow, controversial space where hard physics meets human perception. We are asking whether effortlessness is not about force, but about probability. Whether manifestation, stripped of exaggeration and superstition, might simply be the human experience of navigating a universe governed not by fate, but by likelihood. Because if quantum physics has taught us anything, it is this. Reality is not as rigid as it appears, and the most powerful forces shaping our lives may be operating quietly, far beneath our awareness, in the mathematics of possibility itself. If you enjoy long-form science documentaries that explore the deeper questions behind reality, subscribe to The Boring Universe like this video and leave a comment. And tell us which part of the country you're watching from. At the beginning of the 20th century, physics was supposed to be finished. The universe, according to the dominant scientific view of the time, was a vast but orderly machine. If you knew the position and velocity of every particle, you could predict the future with perfect accuracy. Cause led to effect, and uncertainty was merely a temporary inconvenience caused by incomplete measurement. Reality itself was assumed to be fixed, objective, and independent of the observer. Then quantum physics arrived and quietly dismantled that confidence. The first cracks appeared when physicists began studying light and matter at extremely small scales. Experiments revealed behavior that made no sense within classical frameworks. Energy appeared in discrete packets rather than continuous flows. Electrons behaved like particles in some experiments and like waves in others. Outcomes could only be described statistically, not deterministically. At the heart of nature, certainty dissolved. One of the most unsettling discoveries was that particles do not possess definite properties until they are measured. An electron does not have a precise position or momentum simultaneously. Instead, it exists as a wave function, a mathematical description of probabilities. Only when an observation is made does this cloud of possibilities collapse into a single outcome. This was not philosophical speculation. It was the only model that accurately predicted experimental results. The implication was deeply uncomfortable. Observation was no longer a neutral act. It was woven into the fabric of physical law. The universe, at its most fundamental level, seemed to require interaction in order to decide what happens. Physicists argued fiercely about what this meant. Some insisted it was merely a limitation of knowledge, not a feature of reality itself. Others, including figures like Niels Bohr and Werner Heisenberg, accepted that uncertainty was intrinsic. Reality, they argued, does not exist in a fully defined state independent of measurement. This debate has never truly been resolved. What matters for our discussion is not which interpretation is correct, but what they all agree on. The universe does not operate like a rigid machine. It operates like a system of probabilities. Outcomes are weighted, not guaranteed. And at the smallest scales, the future is not predetermined. This probabilistic nature scales upward. While quantum effects average out in large systems, they never disappear entirely. Every macroscopic event is built upon countless microscopic interactions, each governed by probability. The stability of the world we experience is not absolute. It is statistical. This is where the idea of effortless manifestation quietly enters the conversation, not as magic but as alignment with probability. In everyday life, we rarely think in terms of likelihood distributions. We think in terms of effort, intention, and outcome. We believe that pushing harder should produce better results. But physics suggests that effort alone does not determine what happens. It merely increases certain probabilities while decreasing others. Two people can apply similar effort and still experience wildly different outcomes because they are not interacting with a deterministic system. They are interacting with a probabilistic one. From this perspective, effortlessness does not mean doing nothing. It means operating in a way that consistently nudges probabilities in a favorable direction. The person who appears to manifest effortlessly may not be bending reality, but navigating it with less internal resistance. Resistance, in this context, is not mystical. It is measurable in behavior, perception, and decision-making. Cognitive science has shown that expectation shapes attention. Attention shapes action. Action shapes opportunity. And opportunity feeds back into expectation. This feedback loop is not supernatural, it is neurobiological. But it exists within a universe that does not guarantee outcomes, only tendencies. Quantum physics does not claim that consciousness creates reality in a literal sense. That idea is often overstated and misunderstood. What it does show is that the observer cannot be cleanly separated from the observed. In human terms, this means that perception and participation are inseparable. When someone expects failure, they unconsciously filter information differently. They notice obstacles more than openings. They hesitate at moments where others proceed. Over time, this alters the probability landscape of their lives. Not because the universe is punishing them, but because they are interacting with it differently. Conversely, when someone expects alignment, they are not immune to failure, but they respond to uncertainty with motion instead of paralysis. They exploit small advantages. They interpret ambiguity as opportunity rather than threat. This shifts outcomes gradually, not instantly, but noticeably. The illusion of effortlessness emerges when probability has been shaped long before the visible result appears. This is why manifestation narratives often feel misleading. They compress timelines and exaggerate causality. They imply that a single thought produces an immediate outcome. Physics offers no support for this, but it does support the idea that repeated patterns of interaction, guided by perception and expectation, alter statistical outcomes over time. In a probabilistic universe, consistency matters more than force. This perspective reframes success, failure, and luck. Luck is not randomness alone. It is randomness filtered through preparedness, perception, and timing. Two people can encounter the same opportunity, but only one recognizes it as such. That recognition is not mystical. It is cognitive, shaped by belief and experience. Quantum physics does not endorse belief as a force. It endorses interaction as unavoidable. Every measurement, every choice, every action participates in shaping the next set of probabilities. The universe is not listening to our thoughts. It is responding to our behavior within its rules. Effortless manifestation, then, is not about controlling reality. It is about reducing internal conflict with how reality actually operates. It is about moving with probability rather than against it. This is why forcing outcomes often backfires. Force narrows perception. It increases stress, which impairs decision-making. It reduces sensitivity to subtle feedback. In a probabilistic system, this is a disadvantage. Calm attention, by contrast, broadens awareness. It allows for adaptation. It increases the chance of recognizing favorable shifts. Over time, this produces the appearance of ease. None of this guarantees success. Quantum physics does not promise fairness. Probability distributions still include loss, randomness, and failure. But it does explain why identical effort does not produce identical results. The universe does not reward desire. It responds to interaction patterns. This is not comforting. It removes the fantasy of control. But it offers something more useful, understanding. As we move forward, the question is no longer whether manifestation is real or imaginary. The question is what remains when we strip away exaggeration and examine the structure beneath. What does physics actually allow? Where does science end and interpretation begin? The observer effect is one of the most misunderstood ideas in all of modern science. It has been simplified, exaggerated, romanticized, and weaponized by both critics and believers. To some, it proves that consciousness creates reality. To others, it is nothing more than a technical nuisance, a reminder that measurement tools disturb what they measure. The truth is more subtle, more unsettling, and far more relevant to understanding why some people appear to move through life with unusual alignment. In physics, the observer effect does not mean that human awareness magically alters the universe through intention alone. It means that the act of measurement is an interaction, and no interaction is neutral. When we measure a system, we are not standing outside reality looking in. We are touching it. And at the quantum scale, that touch matters. Consider one of the most famous experiments in the history of science, the double-slit experiment. When particles such as electrons are fired toward a screen with two narrow slits, they behave like waves, forming an interference pattern that suggests they pass through both slits simultaneously. But when detectors are placed to observe which slit the particle goes through, the wave-like behavior disappears. The particle behaves like a particle. The mere act of measurement changes the outcome. This is not philosophy. It is experimental fact. The unsettling part is not that observation changes behavior. It is that without observation, the system cannot be described as having chosen a single outcome at all. Before measurement, the particle exists in a superposition, a mathematical description of multiple possible states at once. Measurement does not merely reveal reality. It participates in defining it. Physicists are careful about language here, because words like observe and measure carry psychological baggage. In practice, measurement means interaction with a macroscopic system, a detector, a photon, a device. Consciousness is not required, but the role of interaction is unavoidable. This distinction matters because the human brain is itself an interacting system. Every perception, every decision, every action is a physical process unfolding within a probabilistic universe. We are not detached observers watching life unfold. We are embedded participants constantly altering the conditions of what happens next. This is where simplistic interpretations fail. The observer effect does not mean that thinking about wealth causes money to appear. It means that attention, expectation, and action are inseparable from outcomes in systems governed by probability. Human lives are not quantum experiments, but they are built on layers of probabilistic processes, from neural firing to social dynamics to economic systems. Expectation shapes attention. Attention shapes behavior. Behavior shapes the environment. And the environment feeds back into expectation. This loop is not mystical. It is mechanical. But it operates within uncertainty. Psychology has long understood that perception is not passive. We do not receive reality as it is. We interpret it. We filter it. We emphasize certain signals and ignore others. Two people can experience the same situation and extract entirely different meanings, leading to different choices and different consequences. In a deterministic universe, these differences would be minor. In a probabilistic universe, they compound. Small differences in perception can produce large differences in outcome over time. This is not because reality favors some individuals, but because probability amplifies patterns. A slight bias toward opportunity rather than threat leads to more attempts. More attempts increase exposure to favorable outcomes. Favorable outcomes reinforce confidence. Confidence alters future perception. The loop accelerates. To an outside observer, this looks like effortless manifestation. Internally, it feels natural, almost inevitable. But beneath the surface, it is the cumulative effect of countless micro-interactions with uncertainty. The observer effect, properly understood, does not grant humans special cosmic powers. It removes the fantasy of separation. There is no clear boundary where the universe ends and the individual begins. Every choice is a physical event. Every perception is an interaction. Every interaction nudges probabilities. This is deeply uncomfortable for both skeptics and believers. Skeptics prefer a universe where outcomes are independent of perception. Believers prefer a universe where intention guarantees results. Quantum physics supports neither extreme. Instead, it presents a universe that is sensitive but indifferent, responsive but not personal. This sensitivity explains why internal states matter more than we expect. Stress, for example, is not merely emotional. It is physiological. It alters hormone levels, neural processing, and decision-making. Under stress, humans narrow their focus. They become less exploratory. They favor familiar patterns even when those patterns are ineffective. In a probabilistic environment, this reduces access to alternative outcomes. The universe has not changed. The available possibilities are still there, but the individual is interacting with a smaller slice of them. Calm attention does the opposite. It broadens perception. It increases tolerance for uncertainty. It allows for flexible response. This does not guarantee success, but it increases exposure to favorable probability distributions. Physics alone does not explain this. Neuroscience fills in the gap. The brain is a prediction machine. It constantly generates expectations about the world and updates them based on feedback. When expectations are rigid, the brain resists new information. When expectations are flexible, learning accelerates. Rigid expectations feel like certainty, but they are brittle. Flexible expectations feel like openness, but they are adaptive. This distinction mirrors quantum behavior. Systems constrained too tightly lose variability. Systems allowed to fluctuate explore more states. The metaphor is not perfect, but it is instructive. The people who appear to manifest effortlessly are often those who tolerate uncertainty without collapsing into fear. They move through ambiguity with curiosity rather than resistance. This is not because they believe the universe owes them something, but because they are comfortable interacting with what is not yet defined. Quantum systems thrive on uncertainty. Human systems often panic in its presence. This is where misinterpretations become dangerous. Some narratives suggest that doubt destroys manifestation. Physics suggests the opposite. Absolute certainty is not how probabilistic systems operate. They require openness to multiple outcomes. What matters is not belief in a specific result, but engagement with the process. The observer effect teaches us that participation is unavoidable. Even inaction is a form of interaction. Avoidance alters probability just as surely as action does. This reframes responsibility in a subtle way. It does not blame individuals for every outcome. Probability still includes randomness, external constraints, and sheer bad luck, but it does suggest that internal states are not irrelevant spectators. They are part of the system. Effortlessness, then, is not the absence of effort. It is the absence of friction between perception and action. When perception aligns with how systems actually behave, action feels smoother. Feedback arrives sooner. Adjustments are made earlier. Progress appears faster. The observer effect does not grant control, it grants influence. An influence in a probabilistic universe accumulates. This accumulation is slow, invisible, and often misunderstood. We notice outcomes, not distributions. We see success or failure, not the countless near misses and subtle shifts that preceded them. Science rarely deals in narratives of destiny. It deals in distributions, averages, and error bars. Human experience, however, is lived as a story. We assign meaning after the fact. When someone succeeds after years of alignment, it feels inevitable in hindsight. When someone struggles, it feels personal. Physics offers a colder explanation. Both are navigating uncertainty with different interaction patterns. The observer effect reminds us that there is no neutral stance. We are always inside the experiment. This does not make life magical. It makes it fragile. Small changes matter. Attention matters. Feedback matters. As we move forward, the challenge is to avoid overstating what this means. Quantum physics does not justify wishful thinking. It does not promise control over external events, but it does dismantle the myth that internal states are irrelevant. Probability is the quiet architecture beneath every event we experience. It is not fate, and it is not randomness in the chaotic sense people imagine. It is structure with flexibility, order without guarantees. Every moment unfolds within a range of possible outcomes, each weighted by prior conditions, constraints, and interactions. Nothing is fixed, but nothing is free. In daily life, probability is easy to ignore because it hides behind narratives. We explain outcomes with stories of effort, talent, or luck, rarely noticing the invisible distributions that made those outcomes more or less likely long before they appeared. Physics, however, does not tell stories. It describes tendencies, and the universe operates on tendencies, not promises. When people speak of effortless manifestation, what they are often describing is repeated exposure to favorable probability zones. This exposure does not come from desire alone. It comes from positioning. Positioning in behavior, in environment, in attention, and in response to uncertainty. Each small adjustment shifts the statistical landscape slightly. Over time, these shifts compound. Quantum mechanics formalized this idea at the smallest scales, but probability governs every scale above it. Markets fluctuate, ecosystems adapt, careers unfold, relationships form, all within probabilistic frameworks. No single action determines the outcome, but patterns of action change the odds. The universe does not respond to what we want. It responds to what we do consistently. Effortlessness emerges when those actions are aligned with how systems naturally evolve. Resistance increases noise. Alignment reduces it. This does not mean surrender or passivity. It means working with uncertainty rather than demanding certainty from it. Understanding this reframes manifestation as literacy rather than power. Literacy in probability. Literacy in feedback. Literacy in recognizing when persistence increases odds and when flexibility does. Those who appear fortunate are often those who adjust early, learn quickly, and remain open to multiple outcomes without losing momentum. Quantum physics does not offer comfort. It offers realism. It tells us that the universe is not designed to fulfill intentions, but it is sensitive to interaction. That sensitivity is not a promise of control, but it is an invitation to participate intelligently. In the end, effortless manifestation is not about bending reality to your will. It is about understanding the rules well enough that reality no longer feels like it is pushing back.